and I would like to introduce our novice chairperson, Chris Morisette. Chris is recently back. I think it's been a few weeks, right, Chris, from New Zealand?
Couple of weeks, yep.
Couple of weeks, yeah. And in addition to giving us a tour of the spring night sky, he wanted to share some of the wonderful things that he saw in the Southern Hemisphere that we just don't get a chance to see here in Houston when it comes to the night sky. So without further ado, Chris, I'd like to pass it over to you. Let me stop the share.
All right. Fantastic.
And the floor is yours.
Great.
And for everybody, while this is coming up, if you have questions for Chris, please feel free to use the chat feature that we have in Zoom, and we'll get to those at the end of the presentation here.
Great. Thanks, Joe. I appreciate the introduction. Hello, everybody. I'm using a headset for the first time tonight. So if my voice fades in and out or there seems to be some issues, let Joe know and he'll flag it and we can get it corrected. Okay, great. Well, tonight is going to be really exciting. I'm really psyched up about tonight. We're going to talk about navigating the night sky, and galaxy season is here, and it's one of my favorite times of the year. So we're going to cover navigating the night sky and looking at some great objects and get you kind of primed when the weather clears up for us to go out and do some stargazing. So tonight, what we'll be doing, I'll start out with a little session on navigating the night sky, kind of going through some of the tools, some of the basics, some of the references that'll help you in your endeavor. We'll then talk about the Big Dipper. The Big Dipper is a wonderful signpost for us to use in order to find our way around in the night sky in the spring. We'll go on a spring sky tour. So we'll look at various objects. It's a little bit more focused on galaxies since we are entering the season, but I've managed to throw in a few other objects there of interest. And then I'd like to wrap up with a section I call Astronomy from New Zealand. As Joe mentioned, I had an opportunity to visit down there. It's a fascinating country. And as part of my journey, I managed to squeeze in some astronomy. So I'll share with you some learnings and observations that I made while I was down there. Okay, so navigating the night sky, even if you have an app or you have a go-to mount, you still want to really get familiar with the night sky. I use apps routinely. They're very convenient. They help me understand where I'm at and help me learn. But I always like to try to challenge myself to go out there and just do it by the stars themselves. And I think that's a really great skill to develop and something that I encourage everyone to do. So while the apps are available, learning the night sky is really invaluable. And the first thing you want to do, in terms of learning the night sky, really to learn the constellations. That's really how you get yourself oriented. I like to think of constellations as kind of the individual states on the United States map, represent individual pieces of celestial real estate on the celestial sphere. I also like to couple that with learning the brightest stars. I've found that if I can find the brightest star in Leo, in Virgo, well, of course, Orion has several bright stars, but if you can find that bright star, that will not only let you know, hey, I'm in the right part of the sky, but it also really helps you to put together the configuration of the constellation and where the other stars lay. What is it supposed to look like, and how does it compare to its mythical character? So learning the bright stars, I find to be a helpful tool. You'll see here I've got some bright stars that are shaded out. These are because they are below the horizon and really only viewable from the Southern Hemisphere. But tonight at the end of the program, we'll actually peel off some of those shades and take a look at some of those stars. Debbie turned me on to H.A. Rey, and I can't recommend it enough. H.A. Rey is a children's author, but he put together two really excellent books on astronomy, finding the constellations and the stars. These are written by a children's author, but if you're starting out in astronomy, these are great references. I think one of the key selling features of the H.A. Ray books are his transformation, or his reconfiguration rather, of the object that is supposed to be portrayed by the pattern of stars. So, for example, if you look at this example here, you'll see Orion here depicted as it typically is. And if you look at that, you say to yourself, gee, what exactly am I looking at? But what H.A. Ray has done is he's actually reconfigured the straight lines between the stars, not changing the asterism itself, but just changing the lines between the stars. And what you see there is a much more recognizable figure. So again, wonderful reference. And then he also has star maps in the book itself to put each of the constellations in context with other constellations. So while it's written by a children's author, it really takes you beyond and is very excellent material for anybody getting started in learning the night sky. I'll throw in another plug for my own favorite, the Deep Map 600. This again is a kind of a one-stop folded into a gas station map reference. Has all the constellations. I like it. I do need to come up with a new graphic for this thing, though. It's looking a little worn, but again, another reference for you to use in learning the night sky. Planispheres are always a great tool. So you'll typically see planispheres that are geared for 40 degrees in the northern hemisphere. Houston being at 30 degrees is kind of on the lower range of that. So any standard planisphere, for the northern hemisphere is going to probably be okay and work here in the Houston area. And again, these are kind of like a star chart in a pocket, so to speak, and a really handy tool to, again, help you learn that night sky. You'll also find a lot of good information in astronomy and sky and telescope magazines. Sky and Telescope in particular has star maps for the particular month that the issue is of the magazine is for. It also has a lot of good information about planets, where they're going to be. I know that Jupiter's Galilean moons are actually shown as well. So you get a real wealth of information from Sky and Telescope. And then again, I think one of the best references out there are the skymaps.com website. These are, again, kind of a free month-by-month planisphere that you can download, not only get a simplified view of the night sky, but also get some more information about, what's happening in that particular month. So here we have April 2023, and if I'm facing south, I want to have the bottom of the sheet facing down, and I'll be looking at the night sky as it appears in front of me. If I do a 180-degree turn and face north, I want to turn that thing upside down. And again, that will give me a representation of the night sky as I'm looking to the north. These are free. They're easy to download as a PDF and print out. Wonderful tool. So those are some of the tools that are at our fingertips to use to learn the night sky. Let's just kind of cover some of the basics here. And in this particular diagram, what you're looking at here is the celestial sphere. It was a model that was originally put out there by Ptolemy. While the model itself is flawed and has been kind of moved to the side in terms of how it represents the real depiction of the universe, the original model is a very helpful tool in order to learn the night sky. So here you see the celestial sphere. If you want to find a particular point out in the sky, you can any particular point in the sky, a star, a deep sky object, etc., will have two coordinates, one being right ascension, which is analogous to longitude, and the other is declination, which is analogous to latitude. So with those two coordinates, you can pretty much find your way out in the celestial sphere. The celestial equator is around the center of the sphere, and it parallels our own equator. And then we have the ecliptic. And the ecliptic is the plane in which the sun and the planets actually travel in. And there are also a collection of constellations known as the zodiac constellations. They fall along the ecliptic as well. So Leo, Virgo, Cancer, the constellations that are named after or after the zodiac signs fall along that celestial, not the equator, but along the ecliptic. Okay, so another concept or principle to cover here that's important is that the apparent motion of the stars that we see is really going to be heavily dependent on your latitude. And so, for example, if you're sitting or standing at the North Pole and you look at the night sky, the zenith or Polaris will be directly over your head, and all the stars will rotate around you. And none will either dip above or below the horizon. What you see when it first gets dark is what you're going to see all night. It's just that you're going to be changing the position of your body. As you move farther south, you're going to get a different view. So in Houston, we're at 30 degrees latitude. So Polaris, which is the North Star, sits at 30 degrees above the horizon. And everything, the celestial sphere will appear to be rotating around us from that perspective. And you'll see stars that will actually rise, come up over the, near the zenith, and then go down below the horizon. Some objects, some stars are circumpolar, and they will stay up. They never do set. Others will rise and set. Orion being a good example of that. And then if you do some photography where you aim directly at Polaris and you leave the shutter open for an extended period of time, you'll begin to see star swirls. And what you're seeing in this picture here is Polaris right here in the center. And these are individual stars that have smeared because they are rotating around Polaris. And those are really cool pictures to take. I've tried to do this in the past, but I haven't had much luck. Going back to finding our way around the heavens, you really have to be able to tell where north is in order to find Polaris and get your orientation. So the trick that we'll be discussing here tonight, later on, as well as on this slide, is how you find Polaris. So if Polaris can be found by going out to the end of the cup of the Big Dipper, following these pointers, and then going out until you see Polaris, which is actually the end star on the Little Dipper. So that is a great way to find Polaris and to find true north. Here's the Alaska flag, and the Alaska flag actually references this as well. So you see down here the Big Dipper and Polaris shown as the larger star up here. And again, you follow these two pointer stars, that'll get you to Polaris. So very important concept, because if you've got your star map out there, your sky map, you want to make sure that you are pointing directly north in order to recognize the objects in the sky and compare them to what you got on your sheet. So the Big Dipper is a great signpost for the spring. The reasons for that, Polaris in the early evening is up relatively high in the sky for us, so we can use it through most of the night. It is also a useful signpost during the summertime. In autumn and winter, it's less useful because it's down closer to the horizon, and sometimes we don't have a view of that given any obstructions that may be on the horizon. So for springtime, it's a great signpost, and it will rotate around Polaris throughout the night. Last year, I went out and imaged M81 and M82, which we'll talk about here in a little bit. And it's up around the Big Dipper. And, once everything got set up and running, I had a chance to kind of go out and look at the sky and learn the sky. And the rotation of the Big Dipper was something that you just couldn't miss. One other thing to remember about the stars that are in and around Polaris, because of our latitude of 30 degrees, any stars that are within 30 degrees of Polaris will never dip below the horizon from our perspective. As we go farther north, that radius will expand out. So if, for example, you're up in Portland, Oregon, or Seattle, you'll see an even larger portion of the sky that will rotate around Polaris and never set, so to speak. But this is kind of what the situation is for us here in Houston. And then one other thing to cover here is a little bit more about Polaris. Our Earth is actually, at this point in time, is actually pointing towards Polaris, which is a nice thing. Because it's an easy way for us to figure out where the celestial North Pole is. But that changes over the course of thousands of years. Our Earth is actually spinning similar to what a top or a gyroscope, how it reacts when it's spinning. And you'll see here that this top part of the gyroscope is actually making its own little circle, and that's called the precessional circle or precessional path. So you'll see here in this diagram our precessional path, and this circle will take about 13,000 or 26,000 years to complete. So in another 13,000 years, we'll actually be pointing over here towards Vega, and Vega will be our new North Star. But that's a ways off. So for all intents and purposes, Polaris is it for us and our children and our grandchildren. The top is, or the celestial North Pole, or as was, as we kind of depicted it with that gyroscope, in addition to making the precessional circle, it's actually doing what's called a nutation, which kind of wiggles in and out. And so that's happening as well. And because of that wiggle, star maps, star references, that depict the night sky do require updating on the order of every 30 to 50 years, I believe, is the frequency. Maybe more frequent than that, but those references require more updating, or require updating as that nutation takes place. And the last thing that is really good to learn are how to use your hand to tell distances and degrees up in the night sky. So again, you're out, you don't have your phone with you, so you can't access an app, but you still want to find something out there. This is a great way to measure distances in the sky. So 1 degree is the little pinky, and you like to think of that as maybe going over for a cup of tea. 5 degrees is Scout's honor. The fist is 10 degrees, and I'm trying to think of a positive way to depict a fist. So I kind of hark back to my childhood when the big fight of the century was Ali versus Frazier. So that's the 10 degrees. 15 degrees, of course, hook 'em horns. And then if you're sunny manly out in Hawaii, 25 degrees is going to be followed by a nice mahalo. So spot of tea, Scout's honor, Ali Frazier, hook 'em horns, and mahalo. And those are some really easy ways to find your way around the night sky. Okay, so let's talk about the Big Dipper and how we can use that to traverse the night sky and get to some of these objects we're going to be looking at. So if you remember back in January, we talked about Orion as kind of our winter signpost. It still has some use. Orion has still not gone down over the horizon. We can use it in the early evenings, but as we get into May, it's going to become something that we won't be able to practically use anymore. So what we want to do now is talk about our Big Dipper. So the Big Dipper, as you see here, is what it would look like in the early spring evening facing northeast. In this particular case, it's kind of upside down. So here's the handle, and here's the ladle or the cup part of the asterism. And in this picture right here kind of gives you the nuts and bolts on how to use the Big Dipper. So the first thing we talked about earlier was finding Polaris. So if you go off the 2 pointers over here on the end of the cup and follow that out, that'll take you to Polaris. You can find your way to Leo. And by doing that, you would follow these 2 inside stars in the cup and follow that down through the bottom of the cup, and that will take you to Regulus. Regulus being a bright star, you'll be able to pick that up relatively obviously. And then once you picked up Regulus, you know you're in Leo, and you can kind of figure out what the rest of Leo is going to look like. And then the last, but certainly not least, path of travel is along the handle of the Big Dipper. And if you follow this arc, you'll arc to a star called Arcturus. And Arcturus is a bright star in the constellation of Bootes. And we'll go down here. So you can arc to Arcturus and you can get to the constellation of Bootes, but you can also take it a step further and speed on to Spica, which is the bright star in the constellation Virgo. And since we're in galaxy season, Virgo is a wonderful place to be because you have a plethora of galaxies to look at. So these are some really quick, easy ways to help you navigate your way around the night sky using the Big Dipper. And with that, let's get into our spring sky tour. All right, so we're going to start out and look at a couple of objects here. The first one I have here is Alcor and Mizar, a very easy double star to go after. It is the middle star in the handle, but if you take a closer look at that, for me, taking a pair of binoculars, you can easily make out two stars. These 2 stars are about 82 light years away from us, and they are a double star. And obviously they are in Ursa Major. So that's a quick, easy one to start out with. And the next one, excuse me, is M51, which is a galaxy that is about 3.5 degrees off the end of the Big Dipper. And here is M51, or otherwise known as the Whirlpool Galaxy. This is a great galaxy to go look at because if you remember back in February, we talked about galaxies and how they're shaped and influenced by their interaction with other galaxies. And this is a really great example of that. You can see M51, which is the large spiral galaxy up here, getting a slug of gravity from its smaller companion, NGC 5195. And NGC 5195 is actually pulling on M51 and really making the spirals pronounced. So it's a great example of galaxy interaction. Okay, so the next galaxy we want to look at is M101. And M101 is about 5 degrees above the handle between Alcor, Mizar, and Alkaid. If you remember, 5 degrees is going to be 3 fingers. And this galaxy here is called the Pinwheel Galaxy. And it is about 23 million light years away from Earth. It is 162,000 light years in size. So it's about 1.5 times the size of our own Milky Way. Couple of things to note about this galaxy. There are a large number of star-forming regions in this galaxy, and there were 3 supernovas that were observed from M101 back in the last century. So very beautiful galaxy, a lot going on. The thing I like about this one is it's got these very pronounced spiral arms, but the center of the galaxy is somewhat offset. But this image was provided by Jeff Lepp. I cropped it a little bit to make that a little bit bigger. I don't think it ruined the clarity of the picture, but again, wonderful object to go view this spring. Okay, the next object we're going to be looking at, again, another galaxy, in this case, a pair of galaxies, is M81 and M82. And you get to those guys by kind of looking at this top of the cup of the Big Dipper, and then maybe slanting it up just a skosh and going out about 14 degrees in this direction. So in this case, we'd be hooking them horns, and that'll get us in the neighborhood. And here are M81 and M82. Again, another example of two galaxies that have interacted with each other gravitationally. In this case, M81 has really disrupted M82 and has really accelerated the star forming rate in that galaxy. And it's a wonderful object to go look at and view. I don't know if you can see it with this picture, but it's actually a red crease here in the middle, and that is evidence of this sped up process of star formation. So really wonderful pair of galaxies here to look at. Okay, well, galaxies are great, and we'll be taking a look at some more here. But there are also some other objects out here. For example, we're going to be looking at M3. Excuse me, just a second. Thank you. M3 is a globular cluster. And so we talked about arcing to Arcturus, and this is Arcturus right here. And if you go about 10 degrees in this direction from Arcturus, you'll end up at M3. And M3 is actually in a bordering constellation called Canes Venatici. So that is M3. And this is a wonderful picture of M3. Again, a globular cluster. This object is about 32,000 light years away from us, and it has over roughly 500,000 stars in that cluster. And since we're getting into galaxy season, that means that the position of the Earth relative to the Milky Way's galactic disk, we're actually beginning to look out away from the disk, which allows us to see the galaxies, but also allows us to see these globular clusters, because globular clusters, for the most part, reside in the halo of the Milky Way. So again, these are some great objects to go after this time of year and to view. I think globular clusters is one of the most beautiful objects out in the night sky. Very interesting, very mysterious. We're going to get a presentation later in the year on globular clusters, and I think I'm anxious to hear that, because there's a lot about globular clusters I just don't understand. Okay, so you remember we could arc to Arcturus, which we did in order to find M3. And now what we're doing is we're speeding to Spica. And when we speed to Spica, we get to the large bright star in Virgo. And Virgo, there's a lot going on during galaxy season. So for example, you have a Virgo cluster, which is a cluster of galaxies up in this region. So if you look at the mythical depiction of Virgo, it is a lady, and her legs are down here, and her upper body and head is up in this direction here. And this is where the Virgo cluster of galaxies is, up in this neighborhood here. There's another galaxy down here called M104, which is the Sombrero galaxy. Very vivid, stark-looking galaxy that we'll look at. And this baby is about 7 degrees from Spica. I didn't have a chance to get the distance here, but if I had to guess, it's probably somewhere in the neighborhood of 30 degrees from Spica up to the cluster here. And one of the subsets of the Virgo cluster is called the Markarian chain, which you see here. And it's just a stretch of galaxies that forms part of the Virgo cluster. And this is kind of one of the neat things about galaxy season. You can get a wide field shot or view, if you will, of galaxies where you have many galaxies in the picture. And then if you have the right equipment, you can zero in and really take a closer look at some of these individual galaxies. So that's kind of the neat thing about the Virgo cluster, and in particular the Markarian's chain. The Sombrero galaxy is really cool looking. So it is very pronounced. This galaxy is about 28 million light years from Earth. It's about 7/10 the size of our own Milky Way, edge to edge. But it's got this edge on. We have this edge on view of the Sombrero galaxy, and you can really make out the dust lanes and the bulge that's in the center of the galaxy. I just love this piece right here where you get this dark, dusty dust lane right here in front of that bright glow off of after the rest of the disk in M104. So again, this is a great example, neat galaxy to go after and look at. We'll now go to Cancer and look at the Beehive cluster, which is M44. I'll turn over my cheat sheet here. And M44, you can get to a couple of different ways. If you are able to still use the Orion signpost and find Gemini, finding Pollux, the star that's right here, that is about 12 degrees. The Beehive is about 12 degrees from this point. If you are using the Big Dipper and you go from those two inside stars that are on the cup down to Regulus, which is here, then you can go over about 18 degrees from Regulus and get to the Beehive cluster here. And it is in one of the zodiac constellations, which is Cancer. And the Beehive cluster is an open cluster, has approximately 200 to 350 stars in it. And as luck would have it, when you go out and look at the Beehive cluster, you're going to be facing south. And I'll give you just kind of a preview of astronomy from New Zealand, I've got the Beehive cluster there. In that particular case, I was looking at the Beehive cluster, but I was facing north. So a little bit more to come on that here in a second. But again, open clusters, really cool objects, and this is a great example of one for the springtime. We'll wrap up here with some galaxies in Regulus, in Leo, excuse me, which Regulus is the bright star. Here we have two of the Leo triplets. So we have M65 right here and M66. I think I got that right. These galaxies are about 40 million light years away, so they're really out there, really far away, and they are roughly the size of our own Milky Way. So those are two of the three. Here's a picture that shows all three. So you have M65, M66, and then you've got this edge-on galaxy called NGC 3628. And here again, it's another great example of seeing multiple galaxies, multiple objects in one frame. And then if you've got the right equipment and right conditions, you can hone in on a particular galaxy and really get an up close and personal view of that. So those are the objects that I wanted to share with you tonight. There are many more. And again, going back to our references, you can find many more objects to look at during the course of the spring. For the ones that we looked at tonight, I provide you with this table. These are my suggestions to kind of give you an understanding of the type of equipment that you may need in order to view these things. It's not gospel. I'm sure there are people that have used smaller telescopes to find some of these. And if you have, please let me know, because I'm always looking to update these charts. And again, I provide this for you just as a way to get started. Nothing more, nothing less. And then in addition to the objects that we discussed, there are also some upcoming celestial events for the spring. And in particular, I have here some meteor showers that are going to be occurring this month. So the Lyrids that will be happening between April 14th and April 30th. The big show happens the night of the 22nd, the morning of the 23rd. And you can find these by navigating to Lyra and Hercules, and they're in and around Vega. So that is one meteor shower. The other was the Eta Equards, again in the constellation of Aquarius. And here you have these occurring mid-April through the end of May, with the maximum happening on the 6th. Got a couple of close encounters coming up. I think you can call them conjunctions, but just to be on the safe side, I'm calling them close encounters. So the moon and Venus will be about 5.5 degrees apart on the 23rd. And then the moon and Mars will be about 3 degrees apart on the 25th. So again, some more things to go out and observe in our springtime sky. Okay, so that brings us to our last section here, which is astronomy from New Zealand. And as I mentioned earlier, I was lucky to go down, not only lucky to be able to travel to New Zealand, but lucky to get the weather conditions that I experienced, because it was marvelous weather down there. I have some learning and observing that I did in 3 parts of the country, starting out here in Wellington, which is the capital of New Zealand. I then traveled down to the South Island to Aoraki Mount Cook National Park and did some more learning and a lot of observing, and then down here in Queenstown, which I did some observing down there. Astronomy plays a very prominent role in New Zealand's society. And just to kind of bring that out right away, if you look at their flag here, I've always known that New Zealand had these 4 stars on it, but I didn't know if it really meant anything. Well, that turns out that is the Southern Cross. And the Southern Cross is a very prominent asterism in the Southern Hemisphere. And it's a signpost of sorts that I'll show you a little bit about in terms of using to find the celestial South Pole. So here is kind of a summary of the learning and observing that I did down there. So in Wellington, I went to the Carter Observatory. It has a really nice set of galleries and exhibits called the Space Place, which not only has a lot of the standard information that you'd find with in planetariums or observatories here in the States, but they also had some information that focused in on the southern skies and also on Maori culture, which I thought was really cool. Had a planetarium there that I attended. That was really cool. As I went down from, when I got to the South Island, I rented a car in Christchurch and drove from Christchurch down to Mount Cook National Park. And before you get to Mount Cook, about 40 minutes outside of Mount Cook is the Mount John Observatory at a place called Lake Tekapo. The Mount John Observatory is a full-fledged research observatory that's run by the University of Canterbury. I had it on I said, I gotta go check this out. And one reason or another, I just was not able to fit it into the itinerary. I did drive by and see it, but other than that, I didn't have a chance to go in. And I did attend a second planetary show or planetarium show at the Hermitage Hotel in Mount Cook Village. Really wonderful planetarium there. The people that put that on did a fabulous job. I also had signed up for a stargazing tour down in Mount Cook, but as luck would have it, it was canceled due to weather. However, I did have 3 beautiful, brilliant nights that I got outside with my night photography gear and took some pictures, and that was fantastic. Also did a little follow-up observing down in Queenstown, and I'll show you all of this right now. Well, not quite yet. I'm going to talk about the Carter Observatory first. So this is a observatory that is in Wellington. You get to that observatory by taking the cable car up from street level, and this observatory is actually located in the Wellington Botanical Gardens. So in addition to the observatory, it has some wonderful vegetation to go out and look at. ferns are a big deal in New Zealand, and saw a lot of big ferns. I mentioned earlier about the space place and some of the exhibits they had there. I want to just kind of touch on a couple of these. So let's talk about New Zealand's astronomical attributes. So they have three characteristics. There are three characteristics about New Zealand that make it really special for astronomy. First is latitude. So they're in the southern hemisphere at about 45 degrees south. And this really gives the country some, outstanding views of the center of our own galaxy, or the galactic bulge, as well as some other interesting objects like the Large and Small Magellanic Clouds. So those are the dwarf galaxies that are outside of the Milky Way. We can't see them from Houston, but they are very prominent down in New Zealand. Longitude is another characteristic of New Zealand. So they occupy a space on the map that sits between Australia and Hawaii. So if there is some kind of a round-the-clock observation of the night sky that has to take place, New Zealand's situated to take up that gap between Australia and Hawaii. And then the final thing is the remoteness of New Zealand, which makes for extremely dark skies. New Zealand is basically in the middle of the ocean, so it's far, far away from Sydney or Melbourne or any other city that would provide light pollution. New Zealand has a very small population, about 5 million people. So if you take Houston, the greater Houston area, and New Zealand, we have comparable populations. And even their population is concentrated up in the North Island, in the city of Auckland. So the South Island, which is where I did all my observing, has extremely dark skies. And just to kind of give you an idea, Christchurch, which is where I picked up my car, it's north of the national park. It has a population of about 400,000. So it's a little bit bigger than Corpus Christi, but it's 200 miles north of Mount Cook National Park. The other city that is a quote unquote a city on the South Island is Queenstown, and it has a population of 50,000 people, and it's 160 miles south of the park. So Mount Cook National Park is just out in the middle of nowhere. It is just perfectly suited to have some really nice dark skies, and they were dark. I mean, I've been to Fort Davis and I've seen the skies out there, and I would put Mount, just subjectively, I'd put Mount Cook on a par with Fort Davis. It's extremely dark out there. And so, that's a really neat feature about New Zealand and about astronomy. The other thing I ran into is the Maori culture. The Maori are the indigenous people to New Zealand. They're part of the Pacific Island community of people. They originally migrated from Polynesia, which I think is modern day Tahiti, Samoa, Tonga, those islands. They migrated from that part of the Pacific Ocean to New Zealand about 800 or 1,000 years ago. Now, the amazing thing about the Maori people, and really all the Pacific Islanders for that matter, is they navigated in what amounts to canoes over thousands of miles, and the Pacific Ocean is just vast. And in order to pull that off, these people had to have an intimate knowledge of the night sky in order to navigate. So, I mean, it just kind of blew me away. I'll just share this little story I had. I flew from Houston to Auckland nonstop. So I got a flight on Air New Zealand here at Intercontinental. And, you take off from Houston over Laredo, over Mazatlan in Mexico, and then you're over the ocean. And I remember being, they have a little map in the seat in front of you that you can see your flight plan on. And we were out over Tahiti, in the middle of the flight. It's about a 15-hour flight. And I just was looking at that, and there's all this water, and I'm thinking to myself, man, I hope this airplane was thoroughly checked out, because if something goes wrong, we are in trouble. So, you know, you think about the Maoris and how they were able to navigate these the oceans there. It's just an incredible story, just amazing. I mean, the knowledge and the bravery of the thing really kind of struck me. And like other cultures such as the Greek, the Chinese, the Native American, they have their own mythology. They have their own names for various astronomical features. And I'd just like to share with you one of the myths that they have. There's a person by the name of Tewaka o Tamariti, and I'll be honest with you, I don't know exactly who this person was, but he did occupy a prominent part in Maori culture. He sailed far out into the ocean, and in the course of his travels, he longed to get back home. So he took the glowing rocks from his campfire and scattered them across the sky, and he used those rocks to navigate home. So just a quick, brief story from Maori culture that I thought was pretty cool. Their names for various objects are different, obviously. So, for example, Pleiades is known as Matariki. Orion's belt is known as Tatoro. And the Southern Cross is Te Punga Te Waka o Tamariti. So that's how I kind of figured out that this guy was something special in the Maori culture, because they've got the Southern Cross named after him. So cool stuff, and really interesting stuff. Last thing here I want to just leave you with is this beautiful refractor telescope that they had in the observatory. It is a 9-inch refractor, and it was built in 1869 in York, England. It was brought to New Zealand in 1905 and used to support the colonial timekeeping service. So beautiful piece of equipment. And I think they even today use that for actually observing the night skies. So obviously I was there during the day, so I didn't get to see it in action, but it was a really gorgeous piece of equipment. Okay, so let's get on to some of the other learnings. So this was kind of the key thing that I picked up in the 2 planetarium shows that I went to. And this is how you find the South Celestial Pole when you're in the Southern Hemisphere. They do not have a bright star like we are blessed to have in the Northern Hemisphere. So they have to rely on a couple of different tricks. So what they do is they first find the Southern Cross, which is down here, using the 2 pointers of Alpha Centauri and Hadar. And they use those pointers because there are apparently a number of faux Southern Crosses out there that can kind of get people confused. But if you focus in on these 2 bright stars, that will get you to the Southern Cross. And then once you've located the Southern Cross, you need to locate Aknar, which is another bright star. I believe it is in the constellation Eridanus, and it is over here. So if you're going to find the South Celestial Pole, you put your left hand on Achenar, you put your right hand on Acrux on the Southern Cross, and you clap your hands, and where they meet in the center, that's the South Celestial Pole. There are other ways to find it by triangulating amongst various stars and the large and small Magellanic Clouds, but that's kind of the quick and easy way to do it if you don't have sophisticated equipment to do that. I also want to point this out. Canopus is a bright star in the Southern Hemisphere, but it is actually visible from Houston during the winter. It's barely gets up above the horizon, but it is there. And I made a note of that because that's kind of, if you think about it, it's kind of where our skies meet that of the Southern Hemisphere. So really cool, interesting way to find the South Celestial Pole. So here's some observing that I did on the night of the 13th. I went outside, just a gorgeous night. And as luck would have it, when I first got into astronomy, the first thing that struck my eyes was looking at Orion here from my driveway in Kingwood. And lo and behold, the thing that I saw down in the Southern Hemisphere that struck my eyes was again Orion, only this time it was rotated 180 degrees. So you'll see Betelgeuse down on the lower right and Rigel up on the upper left. And the belt appears to be in the same configuration, only Alnitak, instead of being here, is here. And then, of course, M42 is above the belt. One thing that I'll just share with you, Betelgeuse was was red, had a reddish tint like it does when you look at it here in the US. But Rigel looked a lot white. I was expecting to see blue. That's what I remembered seeing at home. I thought maybe that was a figment of my imagination, but when I got back and I had a chance to see Rigel, it was in fact bluer, probably due to seeing conditions, transparency. I don't know, but that's one thing that I noticed that was different. So that was Orion. After I got done shooting Orion, I had to go out and see if I could capture the night sky above Mount Cook, which is what you see right here. And I took this picture, and I'm working on night photography, so kind of a C plus B minus shot here. But I did notice this cluster of stars, so I went back and did a little research kind of after the fact. Using Sky Safari, I was able to put in my location, date, time, etc. And lo and behold, it's the Beehive cluster that we talked about earlier. Now, you'll notice here that I'm looking north to see the Beehive cluster. When you go out and look at it during your endeavors this spring, you'll be facing south. So again, kind of that quirky, everything's backwards down in New Zealand, Southern Hemisphere thing. The next night I saw this and I thought, all right, I'm going to get a ton of objects in this baby because I'm shooting right at the Milky Way. So I took the picture, and then I had the awareness to go out and just take a screenshot off of one of my apps to, give me an idea what it is exactly I'm looking at. And lo and behold, here I got Hadar and Alpha Centauri, which are the 2 pointers. Now, at this particular time of night, they would be pointing up towards the Southern Cross, and unfortunately, the Southern Cross was not in my field of view. So a couple of nights later, I'm thinking, well, shoot, I can't leave New Zealand without getting the Southern Cross. So I got up early down in Queenstown. My focus was on, eating breakfast, getting out on the hiking trails before the parking was taken up. So I opened up the drapes to the hotel and I noticed, hey, there's still stars up in the sky. So I said, all right, I'm going to get a picture of the Southern Cross. So I took this picture with my phone, and lo and behold, I got them. So here's the Southern Cross, and here are the pointers. And you can verify that this is the Southern Cross. If you look at this asterism up here, you'll see that it kind of is kind of like an upside down cup or a flag or something of that nature. So yes, indeed, I got the Southern Cross. That was great. And then I was looking at this picture somewhere and I go, well, what the heck is this? Maybe that's something. So a little bit more research, and it turns out that's the Carina Nebula. And I thought, well, is that possible? I wouldn't think it would be that bright, but it actually has a brightness of about plus 0.8, which is pretty doggone bright. So again, looking at the star patterns, that tells me I got the Carina Nebula. And then I started looking over here, and I thought, during the day, you'd get glare off your camera and you'd get artifacts like this on your lens, but it was night. And I thought, well, what the heck is that? And by golly, I think I got the Large Magellanic Cloud. Again, if I look at its position, the stars around it, you can see kind of the cloudy bands right here compared to here. I think that's what I got. So again, I thought it was this probably the most unique picture I took, because there are a couple of things in here that were really surprises. And that kind of leads me to the wrap up to here, is to get out there and stargaze, because it's a lot of fun and you just never know what you're going to run into. So anyway, with that, Joe, I'm finished, and I would be happy to take any questions that people may have.
Really interesting stuff, Chris. Thank you for sharing all of that with us. And man, I'm jealous. I've never had the opportunity to see the southern skies like that, the furthest south. I've been to Brazil, but it was cloudy the entire time I was there. So, the next closest was Hawaii, and you can see the Southern Cross from there, but it's pretty low on the horizon. So I appreciate the presentation, Chris. That was fantastic. If anybody has any questions, please feel free to unmute yourself and ask those questions to Chris. And while we're waiting, Chris, I was going to ask you, what was your favorite thing to observe down under?
You mean from a astronomical point of
Yeah,
view?
from an astronomical point of view, yeah.
Yeah, I would say the shot of Hadar and Alpha Centauri when I'm looking back at the center of the Milky Way.
Okay.
Now that shot that I said, hey, that looks really cool, but I didn't get the Southern Cross. I thought that was actually the most interesting thing that I was looking at.
Absolutely. I'd love to see Omega Centauri high in the sky as well.
Yeah, exactly. Exactly.
Ray Brogdon said, I know this is being recorded. Can we get access to the recording? Same goes for tomorrow night. Yeah, absolutely. Ray, these will be processed and put on our YouTube site. So look for those in the next several days. But yes, indeed, they will be recorded and shared for everybody to see. Absolutely. Okay.
Chris,
What other
this is
questions?
Michael.
Hey, Michael.
Yeah, Chris, talk a little bit more about, when you're tracing out the constellations and you're realizing that they're upside down. Talk a little bit more about what that must have been like.
That, obviously, well, thank you for the question. It was, it was expected. I, did a little bit of reading up on it before I made the trip down there. But yeah, I mean, it was like, I knew it was Orion, for example, right off the bat because of the 3 stars in the belt. So I knew, just that's a very vivid picture in the sky. And so I knew what I was looking at. But then as you take a step back and you begin to study it a little bit more, you're realizing that, hey, that's Betelgeuse. It's down in the lower right. That is a red star, and that M42 is up above the belt. So it's coming, but when you see it, it's really cool. It's just a neat experience.
So I guess looking through a reflector gives you the appearance of what you would see naked eye here in the northern hemisphere, right? Everything's flipped and backwards. So absolutely. All right. Do we have any other questions for Chris?
I will add something because Chris and I were actually in New Zealand about the same time, and so I was determined to catch some stuff. But the Astronomical League has a Southern Sky observing program, and it just FYI, and I didn't observe enough objects to be able to get that, but it did help me focus on some things to look for, and I found that very helpful. And I took binoculars with me with the intention of finding stuff, and wow, some of those objects were just so cool. I mean, really, really cool. Like the Large Magellanic Cloud, it's huge. I mean, this thing is huge. Like the binoculars, like you have to move the binoculars around to be able to see the whole thing.
Really?
And it's got objects within it too. Yeah, there's
Right.
like a nebula within the Large Magellanic Cloud. So the skies are beautiful. I mean, they really are. If you ever have a chance.
Those objects are very bright.
Yes. Yeah. I mean, definitely the observing program was very helpful. I found it very helpful because I would have been lost. I mean, completely lost otherwise.
Right.
So.
Great. Thanks for sharing that, Liz. Do we have any other questions for Chris? Well, we're waiting to see if there are. I just wanted to share these. So Chris, you mentioned it's galaxy season. These are images that I took using an iPhone. Just a quick snap out of my telescope with a night vision eyepiece. So here's the Sombrero Galaxy on the left, and over on the right, the Whirlpool Galaxy. And I think one night we got really excited. We thought, oh my goodness, is that a supernova we're seeing? But going back and taking a look, we're like, no, we got prematurely excited there. Certainly was just a foreground star. But you really want to make sure that you're in a location, especially for these galaxies, where the skies are dark. Like I said, these were taken in on the left at the X-Bar Ranch for the ESP El Dorado Star Party, and on the right here at the Prude Ranch for the Texas Star Party. So,
and how big is your telescope, Joe?
It's a 25-inch refractor, or reflector, sorry, 25-inch Dobsonian. But like I said, this is kind of what you see in naked eye when you're looking through that in dark skies. So obviously this is amplified, but you know, the photo also reduces some things. So even without the night vision, it looks just absolutely fantastic looking through some of these objects. I know Bram's got a large telescope as well, and a few other members. You know, if you're in dark skies with a nice telescope, you'll be able to see quite a bit of detail in these galaxies. So make sure you come out to the dark site in Columbus if you can't make it out to the Texas Star Party to see some of these galaxies this coming spring. All right. Any other questions for Chris? Perfect. All right. Well, again, thank you, Chris, so much for sharing all of that great information and telling us about all the wonderful things there are to see, not only in the spring night sky, but also down under New Zealand. So really appreciate it. And we'll be back tomorrow evening for our general meeting. We've got a presentation on comets, which should be pretty fascinating. So if you haven't registered for that, look for the emails. You can go to the website. We've got the registration link there. That meeting starts at 7 p.m. tomorrow. And if you're on any of the social media platforms, we've got the links there. Please give us a follow. And as always, if you have questions, send us an email, info@astronomyhouston.org, and we will try to get to those as quickly as possible. So until tomorrow night, everyone have a great evening.